Pre-calculus students, this is the 4.5 video. Well, the first video for 4.5. This will take more than one video. We're looking at the graphs of sine and cosine. Now, first thing to note is that the graphs of these are different than the unit circle. The unit circle is essentially a calculator to help us calculate trig functions. The actual graphs of the trig functions are different. So for sine and cosine, they actually have fairly similar graphs. We're only going to focus on these two. There are graphs for the other functions, tangent, cotangent, secant, cosecant, but we're only going to worry about sine and cosine. They're kind of the two important ones. I've made a link on Blackboard to this GeoGebra file, but I want to just show you a little bit about how these look, and then we'll graph them a little better. So we're going to start off with sine. So this app here actually does a good job of comparing the unit circle to what actually happens. Notice that the sine is starting at 0, 0. That is because when the angle is 0, and I actually have a little angle here of 0, the sine is 0. Now, what happens is, as I start to increase my angle, what I want you to notice is the length of the opposite side of the triangle. This is why we spent so much time looking at these in terms of triangles. That would be the sine. Remember, the red is the sine. So as the angle increases, the sine also increases until it peaks at 1. The sine is 1 when we're at pi over 2. Then the side opposite starts to decrease as we get closer to pi, or 180, and the sine goes back to 0. As we scroll down below, it gets bigger, but in the negative direction, because sine is negative down here, until it bottoms out at -1. And then it gets closer and closer and closer to 0 as we reach 2 pi. Now, this just keeps cycling over itself over and over again, but realize that this wave would actually continue forever and ever and ever. Don't worry about drawing this yet. We'll get much more precise, but the sine wave keeps on going forever and ever in both directions. Now, the cosine wave, if we look at cosine instead, remember the cosine is the adjacent. And at 0 radians, right here at 0, the cosine is 1. So notice that the dot is starting at 1. The length of the adjacent side, which is this blue length going right along the x-axis, that blue length on the triangle is getting smaller and smaller and smaller until it reaches 0. At pi over 2, the cosine is 0. Cosine is negative over here, but getting closer and closer to -1 until it reaches -1. Cosine gets closer and closer to 0. And then it hits 0 at 3 pi over 2. And cosine goes back to 1 as we get to 2 pi. Now again, this would just keep repeating itself over and over again, but it does actually keep going. So just like the sine does, cosine repeats its wave over and over and over again. Goes on forever in both directions. So this app is on Blackboard. I put a link to it. I also have a link to another GeoGebra app that I'll show you in just a second. But let's get the basic graphs of these written down first. So for sine, so this is the graph of sine. And again, it's helpful to think of the unit circle and what happens at those different angles. So let me bring up our unit circle. In particular, right now, let's just focus on the sine, which would be the y coordinates. So when the when the angle is 0, the sine is also 0. So that really is the point 0, 0. When the angle is pi over 6, the sine is 1/2. When it's pi over 4, the sine is root 2 over 2. When it's pi over 3, the sine is so on and so forth. Now, we're not going to plot all these points. These are all x, y coordinates on a graph. What's of importance is when it's pi over 2, the sine is 1. So as I rotate into the angles over here, the sine, the y coordinate, gets smaller and smaller until at pi, it's at 0. And then down here, as the angle keeps getting bigger, the sine gets more negative until it bottoms out at -1. And as the angle keeps going, the sine starts to increase until it gets back. I'm sorry, that was wrong. I was doing the cosine there. The sine, approaches 0 again. Now, the important points that we're going to look at are this one, 0, 0. This one, which is pi over 2, comma 0. Comma 1. This point, which is at pi, comma 0. And finally, this point, 3 pi over 2, comma -1. Well, actually, we'll throw in one more. Our original point could also be thought of as 2 pi, comma 0. So again, these are all points on a graph. So what does this mean? The graph for sine has a point at 0, 0. So 0, 0. It has a point at pi over 2, comma 1. We'll just say 1's about up here. And remember, pi over 2 is just a number. It's about 1.57. At pi, we're back to 0. At 3 pi over 2, we're down to -1. And at 2 pi, we're back to 0. So I can see that I reach up top, I fall back down, and I go back to the start. Now we're also going to graph on the negative side, and I'm going to graph the exact same increments. Pi over 2, pi, these are all in the negatives, -3 pi over 2, -2 pi. Notice that there is a cycle to this. I went from on the axis, above, on, below, on. That same cycle will repeat. Below, on, above, on. And I basically just get another cycle of sine. So sine itself takes a distance of 2 pi to complete one snapshot, if you will, of sine. Notice that it's just the exact same snapshot over here. So this image just repeats itself every 2 pi distance. For cosine, now we're looking at the angles and their x coordinate. So my angles are going to be the same. So that means same thing, 0, pi over 2, pi, 3 pi over 2, 2 pi. But now, when I go to those angles, I'm focused on the x coordinate. on the graph. So 0 radians goes with 1 for the cosine, which also means at 2 pi, it goes with 1. At pi over 2, the x-coordinate is 0. Pi over 2, it's at 0. At pi, the x-coordinate is -1. Now, I know it seems like, oh, wait, you're calling it the x-coordinate, but you're drawing it in the y's. Remember, the unit circle is just telling me the sine and the cosine. And at 3 pi over 2, the x-coordinate is back to 0. So these will all be points on the cosine graph. So for cosine, I'm going to have the exact same increments as I did for sine. And again, some better drawings are on my posted answer key to the note packet. But cosine, at 0 radians, the cosine was 1. At pi over 2, it was 0. At pi, it was -1. At 3 pi over 2, it was 0. At 2 pi, it was 1. Notice this exact same pattern as sine comes through on cosine. We're either above the axis, on, or below, and then we just keep a cycle going. So this would represent one cycle of cosine. If I keep the pattern going, on the axis, below, on, above. That exact same cycle repeats itself over and over again. So just like with sine, a snapshot of cosine takes 2 pi to complete. If I look over here, this is just another snapshot of cosine. Oops, moved my whole thing there with me. Let's just draw it again. Over here would be another snapshot of cosine, and it takes a distance of 2 pi. So whether we're talking about sine or cosine, their period, which is the cycle, how long it takes, is 2 pi, regardless, for the parent graphs here. Now, just like we talked about early on in the semester, we can stretch stuff, we can compress it, we can shift things. We're going to do those same things with sine and cosine. We have some different names for them, sorry, but the ideas are similar. Amplitude is basically just the trig way of saying vertical stretch or compression. When we're looking at our general form, which is here or here, depending on whether it's sine or cosine, but it doesn't really matter, it is the a number. Whatever we multiply out in front of the function stretches or compresses it. So in terms of trig graphs, and this is a different app that I have posted on Blackboard. I've got several functions here, but down on the bottom are sine and cosine. So right now I have sine selected. The a number influences the vertical stretch or compression. So bigger a numbers stretch it, smaller a numbers compress it. If I do a negative, that just reflects. It just reflects it over the x-axis. If I just let this run, I can see that I have sine function being reflected. Now it's back to its normal sine function. and it's just being stretched or compressed based off of the number. An important thing to remember on amplitude is that amplitude is always positive. So even if we have a negative on amplitude, the negative would cause the reflection. The amplitude itself is positive. Positive because it is a distance from the midline, from the middle of the graph. Period is how long it takes to repeat itself, which we just talked about. Sine and cosine both take 2 pi to start repeating themselves. That's how the cycle goes. But we can change that. The B number, whether we're talking about sine or cosine, the B number tells me how many cycles I will see in 2 pi. So let's go back to this app. Oops. The B number will change how many cycles. And so what I want you to focus on is normally it's taking 2 pi to finish one sine wave. If I take B and crank it up to 2, get it exactly at 2, notice now one full sine wave is only taking 1 pi to finish. And that also means that I'm finishing 2 cycles in 2 pi. If I cranked it up to 4, now I finish 1 cycle in pi over 2, and there's actually 4 full cycles by the time I reach 2 pi. Vice versa, if I made B, let's say, a half, now I only see half of a cycle in 2 pi. It takes a full 4 pi to finish 1 cycle, or 1 period of this. So what is all this saying? What this is saying is bigger B numbers give you faster cycles. Smaller B numbers give you longer cycles. And to actually figure out how long the cycle is, or how long the period is, it is 2 pi divided by B. So for example, if the B number on a problem, don't worry about writing this or anything, if the B number was 2, then I would do 2 pi divided by 2, which gives me pi. So that tells me that I will finish 1 full sine wave after a distance of pi radians. If I had let's say it was 4 here. I would do 2 pi over 4, which is pi over 2. That means I'd finish a full sine wave over a distance of pi over 2 radians. And vice versa. If I had a fraction in there, like a half, I would take 2 pi divided by a half, which would mean multiply by the reciprocal and get 4 pi. So that means I would finish a sine wave after a distance of 4 pi. The last thing to talk about is a phase shift. This is just the trig way of saying a horizontal shift. That deals with this C number in here. And it's not quite just the C number though. It is a shift of negative C over B. I won't get into the specifics, but there has to do with having to factor this B number out of this parentheses in order to correctly get the phase shift. And also, on a more generic term, if you remember when we were doing transformations of stuff like x plus 2 squared, something like that. Remember, the plus 2 actually meant go left 2. So I actually was changing the sign. I was shifting -2 over. Same idea here. That's why I stuck the negative on this. So if it was plus c, I would go left c. So phase shifts are basically just horizontal shifts. So looking back at this, a positive number is actually moving me to the left, whereas a negative number is actually moving me to the right. So phase shifts just move me left and right. They're just horizontal shifts. And again, this is up on Blackboard if you want to play with it. I didn't mark or write anything down for the letter D. That's just a vertical shift though, like it's always been. This is just moving the graph up or down. Nothing too crazy about that. So the transformations are actually the same rules we had at the beginning of the semester. It's just now we're applying them to trig functions. So what we're going to be doing on these problems is figuring out all the information, the amplitude. That's basically our stretch or compression vertically, but it's also involve reflection as well. We're going to figure out the period. That basically is our horizontal stretch or compression, the phase shift, which is basically our horizontal shift, and the vertical shift. Notice that in these graphs, I basically, for one cycle of the function, had 4 increments. 4 increments here, 1, 2, 3, 4, where something was changing on the graph. So I always divide the period into 4 increments. If there's a horizontal shift, I'll start there. I'll add that increment 4 times to get my 4 intervals. And then I'll plot key points. So there's a lot to look at here, but it's gonna be the same pattern every time. On the next video, we'll actually start graphing these.